Good day, good day, good day, and welcome to Africa Teen Geek Online School. I hope that everybody's having a great day. It seems sunny on my side, and I hope that you guys are ready for some physical sciences. Yes, indeed. If you are in this class, then you have joined the Physical Sciences Grade 11 class. And yes, I am Nonkululeko Matondo. I am your teacher for this class. I hope that everybody has been having great time, especially with understanding all the concepts that we've been working with. Yes, so far we've been doing a lot of chemistry for the past 3 weeks now. We've been doing chemistry and we've been taking it a unit a day. But with this one, we've merged some of the units because others have been shorter. Like, for example, yesterday we did the 2 units together because one of the units was just roughly about 1 2 pages. So but we are not skipping anything. We are doing everything on chemical change, and I'll explain to you guys why that is so right in a moment. But before we do that, I want to remind you guys that you guys can get me on social media. On LinkedIn, I am Trio Madondo, but you can also get me on my email, which is nonku3.madondo at gmail.com. And if you have any other problems that you're dealing with that we were not able to cover in this classroom, you guys can just send me emails and I'll do my best to explain to you guys. Once again, I'm also reminding you guys that we're working from the Oxford Successful Textbook. That is a textbook that I use. And one thing that I've noticed is that the Oxford Successful Textbook has a lot of information in it and it breaks down a lot of things. But that doesn't mean other textbooks are not good. We also have the Study Master and we also have the Siavula textbook that we're using. They all give out a lot of examples and explanation. So you will notice that as much as I'm doing from the Oxford Successful textbook, there's other stuff that I also get from other textbooks just to make sure that understanding is key in this class. And you can get, of course, the Oxford Successful textbook. You can get it on Snaplify, which is an application that you guys can download and register yourselves, and you can get all your textbooks, not just physical sciences, all your other textbooks or whatever other textbooks you're looking for that is used under the CAPS program, and you can download it. Excuse me, absolutely free on Snaplified. This is going to be free until the end of the year. So I think you guys should take advantage. Download Snaplified. And the nice thing about it is that you can even open your textbooks when you're offline. The ones that you've downloaded, you can see them when you're offline. You don't need data for them because they're absolutely free. And this will help you into understanding more about what you're working with, especially with physical sciences. You guys know you need to understand what you're doing because it can get tricky and they can ask you questions that you have no idea what is going on. Okay, so now moving on, I told you guys that in this week, I will every day of the week I'll be explaining to you guys with the new amendments of CAPS for the final year exam for physical sciences grade 11. Just so you guys remember, make notes, write it down, and make sure that you understand that there is chapters that have been omitted from the program for this year, like chemical systems. Chemical systems is omitted, so it's not going to be counting anything for this year. Wave, sound, and light is also removed from the the CAPS program for 2020 physical sciences grade 11. So you can even see the way your your chapters are weighing. Mechanics is going to weigh 26, electricity is going to weigh 26, matter and material 16, and chemical change 33.3%. So all these 3 weeks that we've been working together, we've been working towards this 33% of your final examination. Okay. Another thing that you guys need to know is that for this year, there's only going to be one paper, not two like all the other years. So it's going to be divided between physics and chemistry. Physics is going to be 18 marks and chemistry will be 70 marks. It's going to be a 3 hour paper. So your questions from 1 to 5 um, is going to be physics and chemistry will be 6 to 10. Oh, another thing that I forgot to mention to you guys from this part is that as much as we're doing chemistry now, because the rules were amended just recently, we had already started with chemistry, but chemistry was moved to fourth term subjects. Okay, so it was moved to fourth term, and we only have electricity for third term. Okay, so if don't mind, let's just finish our chemistry already, because we're already halfway into getting it done. That's why I just thought we should just continue with it, but it is term 4 material. Okay, so I hope that you guys got me there, and we've already spoken about how your papers are going to be divided. So going back to our homework, yes. Ooh, I know you see a lot of papers all over the show, but because I don't like going back and forth in the textbook to look for the question and then coming back to the slides to check the answers, I just put everything in here for you guys to understand. Yesterday, we were doing the reduction oxidation reactions, right? And I gave you guys homework, which is activity 5. So for activity 5, here are the questions right here. I just wanted to put everything just to avoid going back and forth in the textbook. So this was our question, and our questions, they wanted you to, number one, state the type of what is the oxidation and reducing agent, and to mention whether the reaction is a synthetic reaction or a displacement reaction. So what I did here, I put the definition quickly, also from the textbook, pages back, that explains what each reaction is, because as much as they say state whether it's synthetic or displacement reaction, you need to know what it is. So a synthetic reaction is a reaction where reactants react to form a product. So A plus B is equals to AB. That is a synthetic reaction, okay? A plus B equals to AB. So now we also have a displacement reaction where positive ions exchange with respective ions. Ooh, okay, now that one is a bit more tricky, because this one in this case is AB plus D is equals to AD plus B. So they just mix up onto each other and exchange ions, etc. So they do not all give you one product. So that's a displacement reaction. Okay. So now let's go to number one. This is our number one that they gave us. They gave us hydrogen gas plus chlorine gas will give you an HCl. Okay. So now you can see here that you've got two gases, but I need to remind you guys of something else that you guys need to make note, is that in every case, metal is oxidized because it loses electrons, and non-metals are reduced because they gain electrons. Okay, so also keep that in mind. That will also help you in order to figure out, for example, already here, a metal will be the oxidized, because that's what it says. Metals is oxidized because it loses electrons, and non-metals, which is these ones, the gas and the aqueous, they are the ones that become your reduced. Okay, that's also keywords that you guys have to bear in mind. And another thing that we've spoken about before, we dealt with this in the acid-base reactions, which is hydrogen. Hydrogen has a tendency, and it's very malleable, so it can change. It can be an oxidizing agent, and it can also be a reducing agent, depending on what is reacting with. Okay, so don't always think that hydrogen will always be, for example, a reactant or an oxidant. It will always differ according to the reaction. So you see here, because it's both gases, so this one will act as a reducing agent. So it will act as a metal because it's acting with a gas. Okay? Do you guys understand what that means? I hope that you understand. If you don't, guys, please just send me a quick chat, and I'll go through the work again and explain to you wherever you're getting stuck. So don't be afraid. The aim here is for us to understand each and everything that we're doing so that we can be prepared for the end of the year exam. Okay? That's the main prerogative of this program. So here, our hydrogen is going to be oxidized. Why? Because in this case, depending on what hydrogen is working with, it can be um, uh, an, an, uh, an, an oxidizing agent, or a reducing agent. So it can either be a metal, act as a non-metal, or a metal. But in this case, because it's working with a gas, it has to be a metal. It has to be basic. So because they can't both be acidic. With hydrogen, it can change. It can either be acidic or basic according to what it's reacting with. So in this case, it's going to be basic because it's acting with a acid. And why is that, guys? Remember, for a reaction to take place, a base has to react with an acid, or an acid has to react with a base for us to have an acid base reaction. So this is very important. So that's why here our hydrogen is oxidized, and it is the reducing agent because it acts as a metal, and chlorine is reduced, and it is the oxidizing agent. Okay, so this is a synthetic reaction. Why is it a synthetic reaction? Because H plus Cl gives you HCl. So it's not a matter whereby you've got three elements and then they all split in different ways. Here it's A plus B is equals to AB. So that is a synthetic reaction. Okay, so moving to the second one. The second one is more complex. You see, now we've got three agents. I mean, three elements that we're working with. Is Zn will plus H2SO4 will give you ZnSO4 plus H2. So here, it cannot be a synthetic. The one thing already we must know, because A and B is not equals to AB. AB plus BC is will give you AC plus BD, for example. So this case, this we already know, it's a displacement reaction. Okay, ions exchange to their respective negative ions. Okay, so here, you can already see here, this is a solid. Okay, so if it's a solid, automatically we know it falls under metal, and this is oxidized. And what is oxidized is a reducing agent. Okay, I hope that you guys understand what I mean there. Anything that's oxidized is a reducing agent. Anything that is reduced is an oxidizing agent. Okay, if you remember from yesterday how we explained the terms of each. Okay, and here hydrogen is reduced and is an oxidizing agent. So you see the difference here. In this case, hydrogen is an oxidizing agent, and before, with that other problem, hydrogen was a reducing agent. Okay, so that's what we get for number two. And then number three, we've got K plus O gives you K2O. So what is this? We already know A plus B gives you AB. So what is that? That is a synthetic reaction. And now we go back and try to figure out what is what. So here, because K is an S, what do we know about S? S is a metal, and S is oxidized because it loses electrons. So in this case, we will know now that K is oxidized, and it is a reducing agent, which is potassium. Potassium will be our reducing agent. So if this is our reducing agent, then our O2 will be the oxidizing agent because it will be reduced. So O2 here, because it's a gas, which is our term there, non-metals are reduced, then that will be our reduced agent. Okay. Then going to number four. Number four, it's FeS plus Cu SO4. Already this, we can already see it's a solid. So solid goes with metal, and that becomes oxidized. And if this is oxidized, the other one is reduced. If this is oxidized, it means that it's a reducing agent. If this one is if this copper is reduced, it's an oxidizing agent. Okay. So this one, why is it this one? Obviously, it's A plus BC gives you B plus AC. So this is a displacement reaction. Why is it? Because it's not straightforward like AB is equals to C. This one, it's where the positive ions exchange to their respective negative ions. Okay. Guys, I really hope that this has made more sense. This exercise has given you guys more enlightenment on how to calculate and how to recognize agents, reducing agent, oxidizing agent. Guys, these things are important, especially your theory, because you will have theory questions in your exam, especially with comes to chemistry, because chemistry has a lot of theory. Even this that we're doing here, as much as they give you guys a reaction, it's still a theory question. So these are things that you guys have to know and know what to do. Okay. So that was our homework for yesterday. I hope that everybody got it right, and you guys have made all your corrections and now understand what it means. Number one, reactant, I mean, a reducing agent, an oxidizing agent, what is oxidized, what is reduced, and the type of reactions. Because this is something that we went through so quickly, we didn't really explain in detail how to identify the types of chemical reactions for redox reactions. Okay, so this was our homework. So now we are moving on. Yo, guys, we've come a long way and things are speeding up quite quickly. So I hope that nobody is left behind and you all understand what we've been doing. If you don't, send a chat, send an email, send anything. Just make sure that nothing passes you by without you understanding. So on unit 9, now we are dealing with oxidation number. This is a very, very tricky unit, and I hope that you guys are really going to pay attention to it and ask questions. Where you get stuck, ask questions, because if you get stuck on A, you won't be able to do B and C. So it's very important that you understand what you're doing at the present moment. Okay. So what are we going to work with on Unit 9? On Unit 9, number one, we're going to be working with the oxidation numbers. We're going to find out what is oxidation numbers and what do they do. Number two, we're going to do rules of assigning oxidation numbers. Number three, recognizing, oxidizing, and reducing agents. And these last two, we're going to work straight from the textbook because they are more well expanded on the textbooks. And redox reactions involving changes in oxidation number. Okay, so let's get it started. So we're going to start with oxidation number. Okay, what is oxidation number? It's a number given to elements in order to check if the elements are losing or gaining electrons during a chemical reaction. Okay, or we can just give it on a straight term. You can also say it's the number assigned to each element in a compound to track the movement of electrons during the reaction. So basically here, you're trying to know if you have your two reactants and then you have your product, how was the electron transfer during this reaction? Okay, what was used and what was not when it comes to your electrons. Okay, but we're going to work with more example and you guys will understand better. So all bonded electrons are given to the more electronegative atom. Okay, so which means this is basically talking about the bonds. The bonds always go according to what is donated and what needs to be received. So I hope that you guys get that. And also take note that oxidation numbers are not the real charges of the atom. What do they mean by this? You'll see your charges sometimes. It will give you, for example, Mg gives you 2 minus. With oxidation numbers, with charges, the ions, the 2 minus means charges, and the -1, for example, that will be your oxidation number. So the minus sign is before the number for oxidation number and after the number for charges. So what they mean by not real charges is that sometimes you'll have 2 plus on a number on a element that it's standing alone, but once it becomes a compound, you find that maybe they're just going to write a minus. So that's not really the charge number. It is the oxidation number. That's the number after this reaction has taken place and what you get thereof. Okay, but you'll see some more example as we go along. Okay, assigning an oxidation number. Okay, there's many rules to assigning oxidation numbers, and people write them in different way according to how you explain them. But the most important part is that you know the rules that apply for each one that follows. Okay, so number one for assigning the oxidation number is that the oxidation number of atoms in single elements or diatomic elements is zero. Okay, what does it mean by single elements? Single elements, it means, for example, calcium or hydrogen or Zn. Those are numbers that are standing on their own. They don't have elements and they are not, bonded to anything. They must give you a diatom. Their oxidation number will always be zero. Like here's an example that I have here. Or diatomic elements are also zero. Like for example, chlorine gas, hydrogen gas, nitrogen gas. Those ones, it's the same um, element, but it's squared, or maybe it's cubed, or maybe it's four, or it's 6 or 8. H8. All of those, they will give you an oxidation number of zero. So the diatomic elements and the single elements will give you zero. Okay, an oxidation number of zero. And then number two is that oxidation numbers are usually given to most electronegative element first. Okay, in a monatomic compound, for example, ions with one element, they have an oxidation number equal to the charge on the ion. Okay, for example, you for chlorine, right? Chlorine has a minus in the A. I'm sorry to say A, but it's going to be Cl, then it's going to have minus. So there, it means that the oxidation number is -1. Okay, so that's what it means. You already have a charge number. So if they are monoatomic compounds, they will have um, the oxidation number will be equal to the charge number. And for example, magnesium, I know we always use magnesium a lot as an example. Magnesium, the charge is 2 plus. So you see, for charges, the plus is after the number, but for oxidation number, the plus is in front of the number. So for here, because Mg is 2 plus, our oxidation number will be +2, which is what I've just explained, that the oxidation numbers are usually given to the most electromagnetic, but monatomic compounds have an oxidation number equal to the charge. Okay, I hope you guys get that. Okay, oxidation numbers are given based on the ion they would form using group numbers on the periodic table. Do you guys understand what it means when it talks about the groups on the periodic table? The groups on the periodic table, they play a very big role when it comes to oxidation numbers, or even redox reactions. They're very important, but I'm going to show you guys later on as we continue. This is it now. I'm just making the general rules for assigning an oxidation number. Okay, because what is important here, we're going to need this because we're going to calculate oxidation numbers. They might give you a compound and ask you what's the other numbers, what's the other elements oxidation number. You need to be able to calculate that. So that's why we first do the theory and then we do the problems. Okay, always have +1 and +2 oxidation numbers respectively, and Al will be +3. And these are the numbers that we get from our groups, but I'll explain further to you guys how you identify which group and how much the oxidation number or the charge number is for that specific group. Okay, so we know that group 1A is always +1, group 2A is always +2, and halogens are always -1 and positive with oxygen. Okay, so oxygen, oh guys, there's many rules here. I hope that you guys are following on each and every one of them. Okay. On number 4, we have to know that oxygen will always have an atomic number of -2 and -1 if it's a peroxide. For example, H2SO4, those are peroxides. Those ones will consider them as -1, but normally if it's just a normal NO, for example, NO2, then we'll consider it a -2. And for fluorine is always -1. And that's another important thing that you must know, because of the group where fluorine falls under doesn't allow it to be -1. But in this case, it is -1 because it's a rule of assigning oxidation numbers. Okay. So generally, hydrogen, sorry, I forgot to make a space here. Hydrogen is +1 if combined with non-metals, and negative, sorry, that's another mistake. It's not +1. Here it's supposed to be -1 if combined with only metals. So you see, so hydrogen, we've known ever since we started acids and bases that it's very malleable. It depends what it's acting with. It can either act as a base or an acid. And now we learn in this part that even the oxidation number depends on whether it's working with non-metals, it's a +1. But if it's non-metals, then it becomes -1. Please don't mind this. It's -1, not +1. Okay. So another thing on our one of our final rules that we're going to state is that the sum of atomic number for neutral compounds, okay, which means these are compounds that show it doesn't have any minus or positive or a number on top of them here, they just neutral, so which means they are balanced, is equals to 0. So for example, here with K has an atomic number of +1 and Cl has an atomic number of -1. So these ones, they generally become balanced. There's no overcharge, etc. So they become neutral compounds. So if, for example, they give you and ask you what is the atomic number of K, you will know, you'll just understand, you know that Cl is -1, so K will naturally be +1. Okay, I hope you guys understand it. If you don't, guys, send me a chat and I will quickly explain it again. Another thing that we must know when assigning oxidation number, which is last but not least, is sum of oxidation number of polyatomic ions is equals to the ion charge. Okay, so which means that here when we work with these numbers, we're not going to get a balanced thing like this. We'll probably get something like -3 or +1, and now you're going to have to add them together to find whatever you are looking for. Okay, so let's check some examples on the textbook. Here we are. Okay. My textbook and its slowness. I'm just trying to get to where we are right now. But we're basically going to be doing activity 1, finding the oxidation number. Okay. So while we're waiting for my computer, my textbook to unjam itself, I just want us to look at a few examples here. They say here, use the rule given and calculate the oxidation number of the atom indicated in bold type. Okay, so these, for here we've got Ba, here we've got C, NH3, the N, they're looking for the N, and here it's H2S, they're looking for the S. So before we get to this one, let me just because I'm just having a problem with going to the next page of the textbook. while we're waiting for that, we need to continue because we're running out of time. I just want to show you guys how we get the oxidation number of each, okay? Because that's very important. Because what's the point of finding oxidation numbers or assigning oxidation numbers when you don't know how to find an oxidation number? And this is how we have it, okay? This is your periodic table. On your periodic table, you've got columns and you've got rows. Here on our rows, we've got the periods, but on on the top, we've got our group. So this one here, this first line is group 1, but you don't count hydrogen because remember hydrogen can or cannot, can either be positive or negative depending on what it falls under, okay? And then this one is our group 2. And then we've got our group 13, 16, and 17, okay? So these are the groups that we work with when it comes to oxidation number. So group 1 ions will always be a positive 1. So it's this column right here. So Li, lithium, sodium, potassium, and all of these ones will always be positive 1 oxidation number. And then group 2 ions, which is the second row, this will always be positive 2. Guys, this is very important that you know it because you don't have to know each and every one magnesium. You'll have a periodic table in your exam. What you need to know is that this is group 1. It's plus 1 oxidation number. Group 2, it's plus 2 oxidation number. Group 13 is plus 3 oxidation number. Group 16, it's minus 2 oxidation number. And group 17, which is this final row here, it's going to be minus 1. As long as you guys understand that, then you'll be able to do any oxidation number calculation that is asked to you guys because you're going to have to know them. You're going to have to know that C, for example, O is on group 16, it's minus 2. Those are things you need to know. And sometimes you can even write on your periodic table once you get it and say oxidation number, you'll know plus 1, plus 2, and then this one is plus 3, then this one is minus 2, minus 1. Just write them quickly once you get your paper, just for you guys to make sure that you remember them, because once they ask you a question like this, you need to know these things, okay? So hence I said I wanted us to get to this before we can even understand activity 1, okay? So now we go to I'm just looking for the problems. Okay, so I hope that everybody is slowly understanding what is happening right here. And yes, I hope that we're both seeing the same thing right here. Yes. So we've worked with oxidation number. We've also explained how to find the oxidation number. And these are a couple of examples, okay? So example 1, so this is group 1 plus 1 plus 2 plus 3 minus 2 and minus 1. No, I think plus 3 is here. Okay, plus 3 is here. Okay. So now they give us an example. Potassium sulfide is mainly ionic compound. So sulfur has captured the shed electrons. This is indicated by giving sulfur an oxidation number of minus 2, which is S. It's here. So you see, this is minus 2, like I've already explained to you guys, is minus 2. So each potassium is here, it's plus 1, right? So notice that the ionic compound and the oxidation number is the same as the ionic charge. So the oxidation number can usually be worked out from the group. So K is plus 1 and S is minus 2. Okay, so but here we've got two Ks. So this is going to be minus 1 plus -1 for K, and for S, it's going to be +1. I mean, for K, it's going to be +1 plus 1. It's going to give us a +2. And then for S, we've got -2 because it falls under group 16, which is a -2. And both of them will cancel each other out. And that's why we do not have any charge that's outstanding there. Do you guys understand? I really hope that you understand, because we're running out of time and we haven't done most of um, the stuff that you were supposed to do, but I'll just have given you guys one example for you guys to be able to do, activity 1. Okay, I just want to open activity 1. Guys, this is our activity 1. So please, guys, if you don't have the textbook yet, just take a screen grab and go and test yourself, guys. This is important things that you guys need to know how to identify. Use the rules given to calculate the oxidation number of the atom indicated in bold, okay? So for example, with BaO, we know that O already from the rule, I just forgot which number, but from the rule, O is a -2, and it changes if it's a peroxide, because this is not a peroxide. So this is -2. So it means that our Ba will be a 2, because they cancel each other out. It's going to be 2 minus 2, and we have no charges left in there. So this is an example that I've given you guys, but I want you guys to go and try this at home. Please, guys, try the other problems here, and we'll also be checking them out tomorrow. But because we're running out of time, I just want us to continue. So now we're going to go to recognizing oxidizing agents. Guys, please don't forget to do activity 1. We'll do it together again tomorrow. First thing when our classes commence. But I hope that everybody is in line and is understanding everything that I'm saying to you guys. So assigning oxidation number. So here's another example that I've made for you guys. For example, this one is one where it's not balanced, because you're not always going to get a balanced one. Sometimes you're going to get ones that are not balanced. For example, this one has SO, and then it's got a 2 minus there. So this is an example of getting oxidation number for this equation. And what will that be? We know that this plus this must give us -2. It must give us -2. So what are we going to say? We know that oxygen is -2. For oxygen, it's -2. The oxidation number is -2 times 4, because here we've got a 4 here. So this will give us a -8. So what are we going to say? We're going to say x plus -8 must give us -2, which is the charge that is left there. So because we are looking for the oxidation number of sulfur, x will be the oxidation number of sulfur. We make x the subject of the formula, and this will give us -2 plus 8 will give us 6. So which means that our oxidation number for sulfur in this reaction is +6. Do you guys understand? If you don't, this is your time for you guys to ask and make sure that you are in line. Okay, so recognizing oxidizing and reducing agents. All halogens act as oxidizing agents, taking electrons from other atoms and changing their oxidation number. Okay, so this is another important. Remember, halogens, we always spoke about all metals are oxidizing agents. Okay, so do not forget that. I'm just moving quick so that I can get, because we don't have enough time anymore. We've got like 6 minutes left into the lesson. So yes, so now we also have activity 2. Okay, you know what, guys, let's change this. For activity 1, let's do all the odd numbers, so that for activity 2 we can do let's do number 2, because it's 2.1, 2.2, 2.3, 2.4, 2.5, and 2.6. So for activity 1, just note it down, do all the odd numbers, and then here we do the even numbers for activity 2. So I hope you guys understand what it means, because it talks about sulfur are halogens and they act as oxidizing agent. So once you know what your oxidizing agent Obviously you're going to know what's your reacting I mean your reducing agent. You just need to know one. That's the one most important fact. Okay, so halogens are always oxidizing agent. So whatever reaction you find with the halogen, you know that it's a oxidizing agent. So this will help you to understand how to do activity 2, which is recognizing redox reactions. Okay, yes, oxidation and reaction. So please, guys, do this number 2. We'll do it again tomorrow when we start the lesson. Okay, so now we move on to redox reactions involving changes in oxidation number. Okay, so the change in oxidation number during a reaction identifies whether an atom is oxidized or reduced. So oxidation takes place when an atom changes its oxidation number from left to right in a positive direction. Okay, on the number line, which is what you see here, and a reduction takes place when an atom changes its oxidation number from right to left. Okay, so when you allocate oxidation numbers to atoms, apply the rules given. Remember, guys, go to your book. There's a set of rules. There's 8 rules. Make sure that you understand them. Even if the rules can be mixed up or whatever, they all go through the same product. They all tell you the same thing. So there's no specific order for the rules, but you need to know which rules goes with what problem. Okay, the oxidation numbers of some atoms, such as Ns and transition metal, can change depending on chemical formula and the reaction. If the oxidation number of the atoms of the element is unknown, include X. Remember the problem that we just did now? We called our unknown element X. For example, here it is here. Obviously, with N, it's not part of the rules. It's not given. It's unknown. But with K, we know it's +1 because it's stated on the rules. And with O, we know that it's -2 because it's not a peroxide, so it's -2. And now we're looking for X. And we know here, because here there's no number on top, it means that they are all balanced. So oxidation number of K plus N plus O must equals to 0. But with 3, with O, we know that it must be multiplied by a 3 because we've got a 3 subnumeral over there. So it's going to be K plus N plus O will give us a 0. And now you can make your X the subject of the formula and you find your N, which is +5, guys. I hope that you guys are understanding everything that I'm explaining here because it's important. These are the basis for all the calculations that we're going to be doing in our redox reactions. Okay, so then we also have activity 3. I think we likely to do activity 3. Identify chemicals to oxidize from the following reactions. Okay, so activity 3, we'll see if we have enough time tomorrow, we'll be able to do it. But please, guys, you guys are obliged to practicing it and knowing it. The following reaction are in ionic form. To you guys need to always be able to identify. Guys, practice makes perfect. If you want to be a good physician, you need to keep practicing. So do your activity 3. If we do have time tomorrow, I will do activity 3 with you guys. Please take pictures and do all your homework. Don't forget, activity 1, we're doing odd numbers. Activity 2, we're doing even numbers. And activity 3, we will see tomorrow. But you guys have to just do all of them because it will be always be good for you guys to understand what we're doing. This is your physical sciences grade 11 class. My name is Nonkululego Matondo, and thank you guys for being good students, even though you didn't ask questions. I hope that that's because you guys understand what I have been explaining, and we'll do some more problems tomorrow from your homework. I'm giving you guys time to go and do your homework. Please, guys, that is me, Nonkululego Matondo. I'm peacing out. Please remember that tomorrow we are doing unit 10. Practice your unit 10 and do your unit 10. It's a very long question because it's still redox reactions. Please make sure that you guys do it. I'm just trying to find it here, and we're going to continue with our work. Thank you, guys. and goodbye.